here, and we're going to start up with Peter. If you would like to share your screen, Peter, and take it away.
Thank you. All right. So my name is Peter. I'm a developer advocate at Google. And as has been mentioned in the introduction, I'm based in Germany, actually in Hamburg. I lived in London for a while, but we're now back in Germany. A lot of people are always surprised when I tell them that Google has an office in Germany, and we actually do. It's not a small one, but at the moment, everybody works from home, apparently. So I'm super excited to be here with you. Actually, I've always wanted to go to Australia, and I couldn't have imagined that this would be my first time actually speaking in Australia in the virtual capacity. So today, we're going to talk about building SwiftUI apps with Firebase. And I had the idea to give this presentation after I saw Sam present last time. And he gave a really amazing introduction to SwiftUI. So I thought, OK, why not take it a step further and show how to introduce, how to add Firebase to your SwiftUI app. So what we're going to do today is I will show a demo of an application that we're going to build. Then we're going to talk a little bit about SwiftUI and obviously about Firebase. And then I'll share a couple of resources with you for those who want to dig in deeper. So this is the demo application. It is a little application to manage videos, movies that you've watched. It basically uses Firebase to store information about the videos. And in this screen where I can search, I'm using the TMDB API, which basically is IMDb, but with open crowdsourced information. And I added a new movie by basically searching for No Time to Die, the new Bond movie, added it to my Firebase database, and then I was able to see it in the application. So it's a very simple application, very straightforward. So let's first talk about SwiftUI just for a little bit. So those who hadn't had the chance to see Sam talk last time to understand what this is all about. So SwiftUI is a declarative way to build your UI. And this is very different from the traditional way. So usually when you build a UI, you use an imperative way. So you tell your app, do this, do that, and then do the other thing. And by doing a declarative way, you basically just give the application or the compiler a blueprint and tell it, OK, so this is what I want the application to look like. And then the language will take care of that. Another thing that is amazing about SwiftUI is it gives you better state management. So the UI is a function of its state, which means that as you change the underlying data, the UI will update automatically. And as many of us know, this is like a huge deal. So a quick view at how a SwiftUI application actually looks like. So this is what you get when you start a new application. On the right-hand side, you can see what the text on the left-hand side does. So we've got a content view, and it has a body. And this body contains a single text. And this text just says hello world. So it's as simple as that. And the amazing thing is, once you start using Xcode and you go in and make any changes, the preview on the right-hand side updates automatically. So let's take a look at something slightly more complicated. So here we've got a list view, which shows some of the movies that I had in the demo application. And the text that's highlighted now basically goes in and fetches some test data. At the moment, I'm just using a static array, basically, of some mock data to make it easier. And then here we've got a list view. And on the right-hand side, you can see that the list view takes up the entire space of the screen. Then we've got a H stack. And each of those H stacks basically is a row in your list view. So this will be repeated for each of the movies in your movies collection. We've got an image, And below, you can see that we make the image resizable, we change the aspect ratio, we specify the frame we want it to take up. And then we've got a VStack for aligning the texts. And just for completeness sake, here is a text for the item title. All right, so that's a very, very, very brief introduction to SwiftUI. Let's talk a little bit about Firebase. So many of you might know Firebase, but for those who don't, let's take a quick look at what it all contains. So a few people might know Firebase as basically a real-time database, and that is actually what we started out with. So in the beginning, we were just a real-time database, and then Firebase became part of Google, and that was when we added a lot more products. And you can categorize those products into 3 pillars, basically. One pillar for building apps, another pillar for improving your app quality, and a third pillar for growing your app with products like A/B testing, messaging, dynamic links, and stuff like that. But today, we're just going to look at one product, which is Cloud Firestore, which is a document-based real-time database. And so the question is, why would you want to use something like Cloud Firestore? So in many applications, you want to share data between multiple devices. So for example, you might have a to-do list and you want to share data between multiple devices or between multiple users. And this is what Cloud Firestore gives you. It is a cloud-based, document-based, NoSQL database. And some of its features are effortless syncing. So once you connect to Cloud Firestore, any data that you add to the data store will be synchronized to all of your devices. Any changes that you make on any of those devices will be synchronized between those devices and all your other devices. It has an offline support, which is on by default. So if you're on a plane, maybe in the future again, or if you are on the tube and you go into a tunnel, you can still continue working with your app and it will automatically resync with your server once you get online again. And then if you don't want to do real-time sync and continuous online mode, you can do one-time fetches as well. So you can say, let me fetch all of this data and then just keep it on the device and then send updates as you need them. What does the document-based part of it mean? So we've got a document here, and Firestore supports a range of types. So we support strings, integers, doubles, Booleans, even binary data, and stuff like arrays and more fine-grained objects. Those documents are arranged in collections. And those collections can contain sub-collections. So you can organize your data in a hierarchical way. So let's imagine you have an application that is about restaurants. And then you organize all your restaurants in a collection called restaurants. But you don't want to see all those restaurants. You want to query them. So you can specify a couple of query parameters, like, I just want to see all the restaurants in Cairo, and I want to see them by order of their rating. So that's easy enough. But the cool thing about Firestore is that no matter how large the number of documents in your collection is, it doesn't matter for the speed of your query. So the speed of your query does not depend on the number of documents, but it depends on the number of the elements in the result set. So let's imagine you've got all the restaurants in the world in your collection, which might be several million probably. And then you just request the ones in Cairo, which will be a much smaller number. And this will be really, really fast, no matter how many restaurants you've got in your main collection. All right. Let's jump into how to fetch data from Firestore in the Swift application. So there are two things that you need to do. One is you need to set up your model, and this is what you see at the top of the screen here. We've got a struct which represents a movie, and you can see that it's got a number of attributes such as title, release date, and rating. And I've done two things here. One is I made this movie codable, which means that Firestore will be able to marshal the data from a document to your Swift struct in a very, very simple way, as we can see below. And the other thing is I made it identifiable, which is important for using it in a list view. And by using the add document property wrapper, I will be able to basically map the document ID from database onto this ID attribute here. Down here, we go to the database, we tell it we want to read the collection movies, and we attach a snapshot listener, which will call us back every single time there is an update to the movies collection. It will call the closure that you see at the end of this line. And then in the closure, we will take all those documents that we received, run a compact map across those documents, and then this is where the magic happens. We will tell each of those documents, OK, let's take the document and transform it into a movie struct. And usually you'd have to do this manually, which you'd have to do for each single attribute, and then you'd have to do null checks, type checks, and all of that. Thanks to the codable support, this comes out of the box automatically. So how to save data to Firestore? Well, that's even easier. So you get hold of a reference to your collection, and then you would just say, add a document, and you hand in a reference to your Swift struct. And Swift or Firebase will go ahead and marshal this data and serialize it into a document and add it to Firestore. And this document will be visible for all users, and it will synchronize to all devices. All right, so how do we bring this together? How do we marry SwiftUI and Firebase? Essentially, how to link the collection or the list view we've got on the left-hand side to Firestore and keep those in sync. So it's no promise, probably, when I tell you that it's a good idea to use a solid architecture, and MVVM is one of the ways how you can easily do that and stay sane. So I've already shown you how to build a view. We also had a look at the storage, which is Firestore. And I also showed you the model. Now let's take a look at how to implement a view model. So here, again, is the model. And here we've got the view model, and it's got two interesting aspects. So the first aspect is that it is an observable object, and that means that we can use it in a SwiftUI application and tell our view that it should listen to any updates that happen on this observable object. And it will listen to all the published properties on our observable object, and I've marked one of the properties here as published, the movies collection. So any change that I make to the movies collection will be visible to the view, and the view will re-render every single time we make a change. So if we add a new element or if we change an element, that will result in a re-render. And down below, oh, sorry, let me go back one. And down below, you see the subscribe method, which basically goes in, subscribes to a movies collection, and does all the snapshot listening and mapping part that I showed you before. OK, next slide. So this is the the view, it's a simple view. And as I mentioned, we're subscribing to the movie view model by using the addState object property wrapper, which tells SwiftUI, OK, here is an object that we want to listen to. Please re-render the screen, re-render all the views whenever something changes here. All right, so let's take a look at the demo once more. So on the left-hand side, you can see the application running. And on the right-hand side, we see the Firestore console. And we currently see a document for the movie Titanic. And I will now go in and search for another movie and add it to our database. And what you will see is that as it's added, it will appear in the database, highlighted in green. And now we can look at the document. So we've got all the information of the document here. Let's find it in the application. There it is. And now let's go in and delete the document. And as you will see, it will disappear from the application instantaneously. And this is real-time sync. So that was, and the database actually is running in the cloud. So it's not running locally. So that's another thing to keep in mind. So now let's go in and make a change. So why all the dots in the uncle? Let's remove those dots and write uncle like it's a name. And boom, there is the update. So any change that you make is reflected in your application almost instantaneously. All right. This application is available on GitHub. So you can have a look at the source code, play around with it, star it, fork it, submit pull requests, whatever. If you are even interested in even more material, go to my blog at peterfriese.dev. All the articles in the top line show how to replicate Apple's iOS reminders application using SwiftUI and Firebase, including signing with Apple. And the articles in the bottom row show how to build an application synchronized with Firestore, map data, fetch data, update data, add data, and all of that stuff. And the sample app that we're building in this series is a book writing app, which is something that's rather useful in a pandemic because people read a lot more. All right, and with that, we're at the end. If you want to follow me on Twitter, I am at Peter Friese. I had the impression that you had to plug your Twitter handle from Sam's last presentation. There are a couple of other resources. We've got a Medium channel as well. So let me see if I can quickly highlight that. Yep, this. So if you use Firebase and you'd like to write an article and get it published, reach out to me. There is a Write For Us page on our channel. We're always looking for interesting content, not just for iOS, but for all the other platforms as well. Thanks.
Fantastic. Thank you, Peter. All the claps are going up in chat. That was really awesome. We had a question really early on. Actually, which was from Will, and Will asked how you initially made the decision to use Firebase as opposed to AWS DynamoDB. What were the considerations? I feel like something might be to do with who you work with, but have you got some specific tips on the pros and cons there? Without starting a war?
Yeah, so it's definitely got to do with who I work for. It would be pretty awkward if I worked for Firebase and then I'd start publishing articles about, hey, here's how you use AWS. So yeah, that's about that. To be honest, I don't have any pointers or tips and tricks for choosing one or the other, except for, give it a try. See how it works for your use case, and maybe just start with a simple toy application like the one that I showed, and get an understanding of how the APIs work if it fits the bill.
Yeah, I think that's a really good answer with these sort of things. They all can tend to be very similar, but just try them all and see what one feels best. Yeah. Did anybody else have any questions? You're welcome to unmute yourself and just shout out if you've got a question. All right, well, we might move on, but you can also always ask questions at the end of the night. So thank you very much for that, Peter. That was really interesting.
Thank you.